variables inside here now instead of the observed frequency. So here we have two trucks traveling at the same speed. They are far apart on adjacent lanes and approach each other essentially head on. One driver is going to hear the horn of the other truck at a frequency that's 1.14 times the frequency he hears when the trucks are stationary. We give you the speed of sound here to be 343 again. We want to know the speed that each truck is moving with. So I'm just going to draw two trucks here. I'm drawing it like they're traveling here. They may eventually collide. They're in adjacent lanes, so they won't hit, but basically they're going head on with the same speed. So there's going to be a V here, a V here. Which one do you want to be the source? Which one do you want to be the observer? Doesn't matter, right? Let's let this one here be the source. We'll let this be the observer. We said they are traveling at the same speed, so we do know that Vs is equal to Vo for the source and observer speed. We have V for the speed of sound, which is 343 that I wrote down up here. They're moving toward each other, so we know how we're going to choose the signs. We're going to pick those upper signs again for the equation. But we told you one more thing here about the frequency that is observed. Okay. It's 1.14 times the frequency that he hears when the trucks are stationary. Okay. So what you hear over here is 1.14 times what you hear when the trucks are stationary. Okay. What can I do with that statement there? Multiply it by, not by V, because we're talking about the frequency. And it said that we're doing this, or that we detect 1.14 times the frequency we hear when they're stationary. What does the stationary part have to do with it? Because we're moving here, right? So you hear 1.14 times what you hear when they're just sitting there.
Would you just multiply 343 times 1.14?
That won't give me a frequency. That'll give me some different velocity. That would be changing the speed. If this truck here is stationary, honks his horn, produces some sound, you hear that sound to be whatever note, whatever frequency it is. When the truck is moving, is the frequency that comes from this, or from this source over here, is the frequency that comes from the horn different?
Higher.
Well, what you hear is different, but what it puts off is it different?
No.
So it doesn't matter here when we're saying that you hear 1.14 times what it puts off when it's stationary. The source frequency doesn't change whether it's moving or whether it's stationary. Okay? What you hear is different depending on the motion. But this is a horn. It's going to produce whatever note that it does, whatever frequency it does, whether it's moving or not. Now, what you hear is different depending on where you are, if it's moving or not. But when we said what you hear is 1.14 times the frequency that you hear when it's stationary, that is just 1.14 times which frequency? What variable would I use?
FS?
Just the Fs. It's just 1.14 times the source frequency. That's what we hear. Frequency that's higher by that amount there than the frequency put off by the source over here, which we call it. Yeah.
Did you know that the velocities were the same because they're just at rest? Or-
No, it said in the problem, I think that they're moving at the same speed.
Oh.
They just told us that,
Oh, yeah,
Yeah.
sorry.
yeah, that's okay. Yeah, this doesn't always have to be the case, it just said let's let them both move at the same speed. So, I could put on here VS, VO, just to label these. FS over here is unknown. The speed of sound here is 343. We know they're moving toward each other. Let's set up the equation. FO is equal to V. You pick those upper signs again from the equation up there. So it's V plus VO over the V minus VS, and then multiply by the source frequency. Is that clear on the signs, choosing upper and lower there?
Mhm.
Okay. So, now what?
That just cancels out.
Which ones do?
The V plus V, O, and V minus VS.
They don't cancel because of the plus and minus.
Well, but since they're the same, and we don't know what they are.
These two are the same? Let's go ahead and put those in. Let's choose to write this then as V plus VO, and then V minus VO like that. And you could have called them either both VO or both VS. Well, we can't call them as V though, because it's not the same as that V. But either VO or VS there is fine. Can we cancel these out?
You can cancel it every S, yeah. Minus every net.
Once I put in the other one, yes, we'll be able to cancel those. But what about these in here? Can I cross these off? Why not?
Different signs.
Different signs. These are thought of as being in parentheses, right? This is one whole term right here that I can't cross off this part with that part. Otherwise, everything goes away here. Otherwise, the original equation, these would never be in there if we could cross those off. So be careful with that. I'm just trying to simplify these. Think of these whole terms here as being, one complete term there, V plus or minus the VO there. And you can't separate it by just dividing anything out there. But we can substitute in the FO, which is 1.14 FS. Then you got your V plus VO over V minus VO times FS. And now those FS's, the source frequencies, we can cancel out, because we can just divide both by the FS there. Okay. Is that clear there with that substitution? How are we going to solve that for VO then? The next step here. Yeah. Multiply both sides by the V minus V naught, because you want to get rid of the fraction. And here, let's do 1.14 V minus 1.14 VO is equal to V plus VO. So I just distributed the 1.14 into both of those. The V minus the VO. That's how we got the 1.14 here with both of those terms. And then you should all be able to solve that for the VO. Take the 1.14 VO, move it over to the right side. Take this V here, move it over to the left. So you get 1.14 V minus V is VO plus 1.14 VO. Just added the 1.14 V over to the right, and then subtracted the V over to the left. Everybody okay with that? What about you, James?
We'll be good.
We'll be good?
I'll see you at recess.
Okay. Are you challenging me to a fight at recess? Is that what that means? So we get 0.14 V is equal to 2.14 VO. So I'm just taking 1.4 minus 1 here to get the 0.14 there, and I'm doing the 1 here plus 1.14 there to get 2.14. And then we just divide 0.14 V over the 2.14, and that's the VO. Where the V up here is just that 343 over 2.14 there on the bottom. We get 22.4 meters per second there.
Does it matter, which one you choose to be the, source at the very beginning?
Up here,
Yeah,
no, because they're moving at the same speed, so I could have made this one over here the source, the observer.
okay,
Yeah, and we chose to draw a picture, but they could have been moving this way to get on board, they could have been moving anyway, we just chose this one as the source.
so it could have been F of, let's see,
This won't change though,
okay,
because either way, what you observe, whether it's on this side or this side, the observed frequency is 1.14 the source frequency,
so how did you know that that was the observed and not the
not the source.
source?
Because it said that the one driver hears the horn of the other truck, so when you're hearing it, you are the observer.
Mhm.
What you hear there is a frequency that's 1.14 times the frequency you hear when the trucks are stationary. So what you were hearing is the observed frequency here, that
Okay.
is 1.14 times the source frequency.
Okay,
And switching sides here from here to here won't change this statement here about what you actually hear from the other one. Let's pull out the objectives again and kind of run through some of these again. I'm gonna give you an in-class assignment here in a minute where you're gonna do another problem where you use the Doppler effect, so let's just go through this one more time. I told you, I think last time, that everything there looks like 1 through 5, all from that first day's lecture, was about 38 points on the exam. Number 6 today we did, where I definitely will ask you to state those perceptual variables, which correspond to the frequency, intensity, and harmonics. Sometimes I just give you a little table like I wrote on the board here and have you fill it in with what goes with frequency, intensity, and harmonics. The sound intensity to decibels, I hope that's an easy question. I think it will be. We saw how to do that today. We just did the Doppler effect. There will be a problem on that. As I told you, it won't be simply solving for FO. That may be a part of it, but at some point you're going to have to solve for something other than the FO. Okay. So you should be able to do algebra like we did here to get rid of the things here or to isolate something that's inside the parentheses there of the fraction. Number 9 and 10 was all about standing waves. Yeah.
You said that you were gonna give us IO on the test.
I'm gonna give you that 10 to the minus 12 watts per square meter. I'm gonna give you that Doppler equation, but not tell you what all the O's and S's mean or the signs, but I'll give you the equation, just what's up in there in the box. 9 and 10 was all about standing waves. As I said, there's gonna be something from all 3 of those different types. A string, tube open on both ends, or open only on one end. Okay, so be capable of basically describing anything for all 3 of those situations there. Yeah, the Doppler effect is usually about 15 points. All the questions there from that first day seem to be about 38 when I was adding them up. Standing waves, usually 30 to 40 points. And then questions there on some of those other things like the perceptual variables there, the sound intensity. Number 11 says to describe medical diagnostic and treatment techniques which use ultrasound. There's a section or a couple pages in your book with some interesting information if you want to read that, but I'm not going to test you on that. That would be interesting though for those of you going into sonography. That would be relevant to you, but I'm not going to test you on anything from that part right there. So that's in there on the objectives. I'm going to give you another problem now. Here, we'll have office hours after class if you want to work on some homework stuff. Yeah.
Could you maybe like write on the board the ones that you're not gonna give us on the test? That's
So-
everything.
No, the formulas.
All the formulas from the whole unit? Yeah,
Well,
you
I
got them
don't
in your
know.
notes, but I mean, the only thing I'm giving you is that one right there. Everything else that
Oh,
we wrote
okay.
down is just something that you can memorize.
Okay.
So I could do that, but I'm not gonna write them all down, because you have them all in your notes.
Well, I didn't know which ones you were gonna give us.
Just that, and the constant for I naught, the constants for speeds of sound, things like that.
Okay.